And then he kept yelling, Mac Daddy! And then he was like, Mac Daddy!
Oh gosh, yeah.
And then every day when I walk in the locker room, he's like, have a good day, Abby. And I say, have a good day, Mr. Donahue.
Oh. You're bonding.
It's our thing.
It's your thing. All right. The reason I wanted you guys to grab your calculators is because some of these are probably impossible to do without a calculator. And I want to start talking to you guys about different types of roots. Now, as much as I normally tell you guys to simplify the radicals, we're actually going to do decimals if needed, so you can use decimals.
That's actually wonderful.
For once.
Yeah.
What do you mean?
So, and I want you guys to use a calculator that you're comfortable with, or one that you're not comfortable with, so that you can learn how to use your calculator to put these different things in. I'm assuming square root is okay. The 1/2 power might be a little bit like trying to figure out exactly what you're supposed to do there. Cube root might be something new to you guys in your calculator, and then the 1/3 power is similar to 1/2 in entering that. Is it bright enough over there for your calculator? So do you guys need that light on? Okay. Sometimes the little solar power needs more light. Okay, so going through your calculator to do square root of 9, 36, 15, 24, and then hopefully square root's not an issue, but then powers, like 9 to the 1/2 power, some of your calculators you might have to do little parentheses depending, but just spoiler alert, 9 to the 1/2 power is 3. So if you want to make sure you guys are doing this correctly, you should get a 3. If you're not getting a 3 for 9 to the 1/2 power, you're entering something in your calculator is wrong. So you got to figure that out.
Oh,
Let's figure it out.
I did 9.5 square root.
You need parentheses around the 1/2. So I think on the calculators that don't simplify the radicals, you need the parentheses around the square root or around the 1/2.
I got it.
Yes,
So, well, square root of 9 is it. So then the next thing is asking you to do 9 to the 1/2.
Can you get 8
So take the square root out of it.
What arrows? I got the
For 36?
You got 18. Do decimal order. There you go.
Where does it say pop? Oh, right there. Go ahead.
Okay,
And that's why we're doing this right now. It's kind of getting us all on the same page. Okay, so you're doing 9. So you do 9, and then the little caret button makes it a power, and then 1/2. Okay, so do you end up getting 9 to the 1/2 is 3?
I got it.
I need some help.
Okay.
Got it.
So in this calculator, you have to do 9 and then the power.
I just get like 8th grade math flashbacks.
Power,
And
that's
she
zero.
says,
What?
And then you're going to use parentheses for 1/2.
"That's where my mom-"
I have no idea how to do the next one.
Yeah, I would, just so you can practice it for me,
Hit this
on
one.
1/3. If you want to divide by 2.
Like the little 3 over the square root.
I don't have that.
Maybe like two
Must suck.
What is your basketball? Oh my gosh, you guys.
Mine says syntax
Oh,
error.
I was
No. What's it?
I never even knew there was a variable button.
A variable button.
This one.
Oh, that's an excellent, yeah.
I don't think I got the right answer.
What did you do?
So I went,
You used to use it.
Oh, yeah, so let me explain that. Okay, so hopefully you guys, so square root of 9 is 3, square root of 6, 36 is 6. 36 to the 1/2 power is what?
6.
6. All right, so hopefully you're realizing that the square root of 9 and 9 to the 1/2 power are really the same thing. That's not a coincidence. That's why I tried to show you different ones. Square root of 36 is 6. 6 to the 1/2 is 6. I'm going to explain why that is in a little bit. The square root of 15, what'd you guys get for that?
Square root of 15.
3.87.
3.87? So I said to use decimals here. So 15 to the 1/2,
3.87.
3.87.
Perfect. Doesn't give you that one.
then you need to use the little arrow buttons to make it give you a decimal. So it's this.
Oh.
How do you think it's cute?
Oh, we'll talk about that in a second.
Yeah,
Then square root of 24 is about 4.8989, so 4.9. 4.9. All right, so cube root. This is something that it depends on your calculator, but there should be a button near the square root that has like a little, it probably looks like this, a little X with a root. In my calculator, I hit a 3 first, and then do that, and so the cube root of 8, it's basically saying, it's not saying 3 times that, it's making that the root. And you should get 2.
Whoa.
Yeah, I did.
So cube root of 8 should be 2. We'll
Hey, I got it. Okay.
Wow.
So,
Cube root of 8, you guys find it, now yours I think is the 9. So if you have that math,
Sorry, it was a problem.
there it is.
So you go, I did 3 and then I did 7.
You did? Okay.
I was just.
Does everyone find it?
No.
So, see that little button above this square? So, no, so you can hit this shift key.
Oh.
That. But now, before you do that, you actually have to hit the 3 before that.
Oh, so 3.
3. Yeah, and then 8.
Wait, come on.
So you want to do three. Yeah. Yours is in the back.
Yeah.
Anybody else? You guys all find it? Okay.
Don't you have an E button?
So, cube root of 27 is how much? 3. So what do you think the cube root means? What do you think, like, how are we getting the cube root of 8 is 2 and the cube root of 27 is 3? Any thoughts where that's coming from?
It's 3.
Yeah, go ahead, say it louder.
Oh, because 3 times 3 times 3 is 27.
Yeah, so just like 6 times 6 is 36, 3 times 3 times 3 is going to be 27. 2 times 2 times 2 is going to be 8. So the cube root is saying what number times itself 3 times is going to be that value. Same like there could be a 4th root or a 5th root. We're not going to deal much with those, but that cube root is basically saying something times itself 3 times is going to equal that value. And you're going to notice 8 to the 1/3 power is also 2. 27 to the 1/3 power is also 3. Careful when you guys do this, please use it as a 1/3 and not 0.3. 0.3 is not the same thing as 1/3. Cube root of 15 is going to be a decimal because there's no number times itself 3 times that equals 15. So that's like 2.47. And then the cube root of 24, same idea. But I wanted to make sure you guys knew how to even put this into your calculator. So if I multiply 2.88 times itself 3 times, I get something really close to 24. Okay? So, and so that's what this symbol is. It's called the cube root. So that little. Now, the square root, they're actually, if you want to be more specific, you could write a square root as something with a little 2 there. Kind of like a first power, it's assumed that the square root has a little 2. That's exactly the same thing. So the 3 tells us we're multiplying 3 times. The 2 tells us it's multiplying 2 times, but they don't mention it because it's kind of just assumed. So square root versus cube root. So the idea, though, with these fractional exponents, we're going to get into that today because that's actually telling us what the root is. So for our notes today, we're kind of doing a mixture of two sections. We're not going to get all the way through them because of the fact that this section is kind of big and it's new to you guys. In the title of the section, it says rational exponents. That just means fractional exponents. Rationals, fractional. And then also radicals. So we're going to talk about those two today. So we're going to talk about how rational exponents compare to radicals. So kind of like we were talking about up here, 36 to the 1/2 power is really the same thing as the square root of 36. And again, that's because there's like a little 2 there that we don't write. Since there's a 2 on the bottom there really should be like a 2 there. So if I'm talking about a to the 1/n power, this is really talking about a root. Where do you think the a is going to go? I kind of use inside, just like up here, the 24 goes inside. Where do you think the n's going to go? Yeah, it's like on top of the root. So this is really saying the nth root of a. So n could be anything. It could be 2, 3, 4, it could be 15, it doesn't really matter. So this is the same thing. These are equivalent. Now, where does the 1 go? Any ideas? Yeah.
To the A?
Yeah, it's really like the a to the first power. And the first power we just don't really even write, so we don't really need it. So you can just write this as the nth root of a. The 1 is kind of like not necessary because the first power really doesn't do anything. So that being said, I have a to the m over n power. So we know this is going to be a root. Where's the a going to go? Bottom, like underneath. How about the m? It's going to be its power. So it's going to be like the m power. How about the n? Outside the little root. Now when I do this, make sure the root is clearly like that's the root and it's not like a big n times that root. So if you're not super neat about your handwriting, trying to make sure that n looks little compared to it being, so I don't want you writing like this. So that would be bad, because that isn't clear to me that that's the little nth root, okay? So let me show you with actual numbers here. So if I have a to the 1/8 power, or a to the 3/4. You want to break those two out. A to the 1/8 is really going to be what? It's hard to say, right? So the 8th root of a is the way we would say that. The 8th root of a. How about this one?
4th root.
The 4th root of a to the 3rd. Okay. So those are interchangeable. They mean exactly the same thing. Sometimes this makes more sense. Sometimes this makes more sense depending on what's happening in the problem or what else we're doing with it. All right, so I want you guys to simplify here. So example 1 says simplify the cube root of 125. This might just mean you can put in your calculator. You want to look at the next couple as well? All right, so the cube root of 125, what'd you get?
5.
5. Why is that? Why would you explain that to someone that has no idea what we're talking about? You might be that person, but why is that? Yeah. Because 5 times 5 times 5 equals 125. So 5 to the third is 125. So that's why the cube root of 125 is just 5. All right, 32 to the 1/5 power. 2. It should just be 2. And again, I want you guys to think about why that is. This is really like the 5th root of 32. And that means 2 multiplied 5 times is going to be 32. So this all has like kind of a connection, a reason. Like it's not just kind of just your calculator's doing some hocus pocus math for us. It has like kind of meaning behind it. All right, number 3 is a little bit trickier. The whole thing is being raised to the 1/4 power. 16x to the 8th power is all being raised to the 1/4 power. Any thoughts on what we should do? Distribute that power. So the 16 and the x is going to get it. So I have to distribute it. 16 to the 1/4. The 4th root of 16. So it's actually going to just be 2. So it's some number times itself 4 times going to equal 16. And it's okay to put that in your calculator. I just kind of want you to think about it as well and not just kind of blindly do that. How about the x? What happens with these powers? Do you guys remember what the rule is? Power to a power? Multiply. So I'm multiplying 8 times the 4th. What do I get? 2. 8 times the 4th is just 2, or 4th of 8 is just 2. So that's going to become the x's power.
Okay.
Yeah, it's just weird. It's just something we haven't seen much of before. All right, if you guys want to look at the next couple here, they want you to write it in radical form. So now it's written with the exponent. Switch it over to the radical form. We won't be able to simplify this at all. Switch it over to the radical form. I'll give you guys a minute. And be really precise about how you write it. Don't make your numbers really big or really small if they're not supposed to be. So try to write examples 4 and 5 in radical form.
What's your favorite sweater?
I got 2 more.
All right, so we know there has to be a radical in example 4. So I'm going to draw a radical. Tell me where everything goes. Where does the k go? Inside the radical.
6.
Where does the 5 go? It's k to the 5th. That's its exponent.
Whoa.
How about the 6? That's the little root. So if you want to put that out there, make sure it's not a big 6. So be really careful about that. Now, you could also have the 5, just so you know, that it could be out over here, just so you know, it's okay for that to be the case. But the 5 has to be the power on the k or on the radical. Okay? How is example 5 a little bit different? Catch it? So I'm going to draw a radical again.
Has a variable.
Okay, there's a variable.
The radical has
okay.
to be
So where does the 5 go? Careful.
outside.
Yeah, this one actually goes on the outside. The 5 doesn't have that exponent. So it's going to be a big 5 on the outside. So it's going to be like 5 times that radical. So the 5 is actually hanging out because really the 5's exponent is just a 1. How about the x?
Just basic.
Underneath. The 1,
No,
you can put it if you want. You don't need to. How about the 3?
in the
It's
crevice.
It's the root. Should have crevice.
Crevice.
Sometimes it's really gross. Like, I feel like I need like a Q-tip for the crevice. I don't know. So, and so this is a little confusing, guys. So this is not 5 to the third. So like understand that that's not a 5 to the third power. It's really like 5 times like that. So making sure you're kind of precise about this. Whoever worked on this notation, it's a little bit wonky. So I mean, I wasn't there when they picked it out. So you know, yeah, not quite that old. Okay. All right, and let's switch it to rewriting in exponential form, so the other way. So now these are written as radicals. We want to write them in exponential form instead.
Oh.
And I want to rewrite it with an exponent. And then we'll take a little notes break here.
I'm going to see the story here.
If you guys can rewrite this in exponential form. All right. So what's 4's exponent here? What's 4's exponent? Just a 1. Yep, it's kind of a trick question. It's just 4.
Okay.
Okay. What am I going to write next?
And
And,
third.
okay, careful. Very good. Yep, so careful. What kind of root is this?
It's confusing.
Square root. So it should have like a little 2 here that we don't typically write, right? So like we mentioned that up above, there's like a 2 that's assumed that it's there. So the 2 is the root, so the 3 is its exponent, but it's going to be divided by 2. Because of that root that we mentioned up at the top, that square root, that 2 is assumed to be there. Now the 4 can be here, it could be like if you wanted to put parentheses. The biggest thing is the 4 can't get the 3/2 power as well. The 4 is just kind of hanging out in front. And it's not a 4th root. Okay? Next one. What do you guys want to start with? Well, I'll ask you, what's 256's power? What's 256's power? Yeah. 1, right? Right now it's a 1. When I pull it out of the root, when I make it an exponent, what does it become? Remember, we're talking about, like, back from the start. If I have let's say a to the m over n. So what's this exponent? Yeah. What's it? But you said that 256's exponent was a 1. Just 1/3, yeah? Do you guys see that? So the exponent on the 256 was a 1, but it's being divided by this root. So it'll be 1/3. Then x, what's its exponent going to be?
5/3.
5/3, because that has the 5 with the 3. right? How we do it on this. It's weird, I know. Why don't we take a whiteboard break and practice this a little bit with whiteboards? We've done them for a while.
It's so nice.
It's so nice, yeah.
It's like 40 degrees. Yeah, that's what I thought.
So nice.
Can you grab me one?
I mean, it's nicer than yesterday, but it's not saying a lot.
No.
I mean, the part is yeah. Where's your star? That's okay. Hey, look at the part. I know I'm gonna, someone's gonna get an accident.
Lindsay, I asked for you to grab me one and you did.
Yeah, they're all like, they probably couldn't understand. She verbally, that's how bad.
How bad was it?
The parking over there.
The what?
Parking.
Parking?
Yeah, look at the street. I was better.
Oh, yeah. That big president.
Like in order to get in your car, someone else has to move first.
Yeah.
All right, so we're gonna do some practice with these different roots, rewriting things, kind of trying to rearrange, writing them with exponents, writing it with radicals.
Mine says dino chicken nuggets.
Mine says here is a short name. Mine says I'm 6'5". 4'5". Mine says 4'5". Mine also says math.
Oh, I didn't notice you. Yeah, there is a problem up there if you want to pay attention to the front side of your whiteboard. Oh, this is the graffiti. Yes. 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 Yep. 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 Yeah.
Did you get that? Wasn't it good? Did you?
Yes.
It makes me cry. Oh gosh. Yeah, like tears. Like I have all my eyes on.
I'm psychic confused.
Okay. So guys, on this one, so again, when you guys do this, when you're talking about an exponent, the top number is the exponent, and the bottom number is the radical. So this should be x to the 4/3 power. All right.
What?
No. Can you grab a different marker? It's really hard to see. Yes, yes. No. Yes. You go. Oh, yes. Yes. Yes, you need to do them then, please. Yes. 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 Yes.
No, Maddie.
Yeah.
What?
What's the number? Yes.
This is algebra.
Abby, did you do this one yet?
Yeah. I need to write it again.
I don't know. I don't remember. Well, to make it a power though, make sure it's, that to me looks like n1/2. There you go. Yes.
You know I write big.
I know. I write big too though, so I'm a big writer.
This is my favorite fraction, Abby over Kinsey.
I'm concerned.
Yeah, that's a little questionable. Okay. So guys, in this case, remember that the square root, we assume there's a little 2 hanging out there. And the m's power is a 1. So this is really just going to be m to the 1/2 power. It's the same thing. All right, let's switch over to radical form instead.
Yes.
Well, actually, let's stick with exponents. Sorry, I'm going to change my mind. But I want to do some that have more things going on with it. I realize I should probably. So rewrite with just exponents. Yep. Yeah, that's it. Just exponents. So who the 5 go to? So like bring them. Yeah. 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 Yes. 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 So it should be a Y, but yes. Oh yeah, that's fine. Yeah. I just did no one else simplified that, so yeah, so that's fine. It makes sense. Yeah. We'll flip the fraction again.
Gosh,
That's scary.
Yes. Y to 4. Yes. Yeah, that's cute. Yeah.
Exponent over radical.
So here's now to switch it. And you see that's so we need to switch it so that the 3 is now back to the point of base, so the
section.
Oh,
Looks like
what did
this.
you do? Yeah.
Oh,
number on the bottom
That's like and she looks
I'm both better. My shape is more.
We'll talk about it later. So, you guys, so 5 to the second, nothing happens. But then the y to the first, this really becomes y to the 1/3. Again, because the exponent's on top, the radical's on the bottom. All right, let's try.
He's definitely
All right, rewrite with exponents.
so weird.
Is radical form coming up?
Yeah, we're doing that next. Yeah. 7 needs a power though.
Oh.
7 is great. Yes. Of course. Yeah, that's good. Little dance maneuver. Yes. Yeah, that looks good. We're trying to rewrite this with exponents. Yep.
Oh.
Yep. Your x is not correct. Your x is not correct. Your x is not correct. You're done.
It's wrong.
Yes. Yes. Yeah. Your x is not correct.
Oh,
Is this
okay,
good?
they're all being multiplied over 2. So you're really close.
So they're all in that same square root. So they all should have the same denominator.
There you go.
So yes, very good. So I'm going to try guys real quick. So Cassidy did use a different, so like Cassidy did something a little bit different. So since this is a square root, she said, well, all of these are just being raised to the 1/2 power. So she did that all at once, that's fine. Otherwise, all of these are getting the 1/2. So 7 to the 1/2, x to the 3/2, and y to the 1/2. Okay? We're going to switch over to radicals now. Okay, 5x a 2/3. Rewrite with a radical. Good job. Not quite. Yes. Oh, yeah. Not quite. Yeah. No, this was 5. Yes. Yeah. I'm sorry to look that surprise. Yes. Not quite. Yes. Yes.
Wait, it's
two,
exponent over
Yeah. Yeah. Yeah.
I think I have one.
No, not quite. No, it's good. Yeah, so the 5 isn't getting that power, so it should be part of it. So you guys, this 5 has like a first power that we don't really write. So the 5's not part of this exponent at all. So the 5's on the outside, and then this is the cube root of x to the second. So the 5 wasn't part of it at all, so we can keep that out of it.
One more.
Yeah. I think
One more. Oh, God. Is that an any or no?
Howdy.
I hate it, I hate it. There's one pattern.
Yeah.
Shoot.
You put your So we're rewriting it with radicals this time, guys. So we want the little check mark thing. So we don't want the fractional exponents at all anymore. Everything should become a radical.
Oh.
What?
Yeah. Yep. Yes, that's it. Yes, that's it. No more fractional exponents at all. What? Yeah, you shouldn't have fractions as your exponents anymore. Yes,
Okay, this is just an exponent.
yes.
I just draw my numbers really big.
That's the group. So the 4 is also getting that, so it should also be under. Yeah. You want a radical. So
Radical.
you don't need it, so make this like longer and just stick this. Okay, so this is good. She's thinking we want that, but then now put the x as part of this. So what's the x's exponent? There you go. That's it. So guys, since this is in parentheses, yeah, this whole thing is underneath the same group. This is all underneath the Q group. So the 4 is under there, but then also the x to the 5th. So just moving the whole thing underneath the 3rd group. I couldn't even tell what she was doing. I was like, I should keep touching her with that.
Yes, I literally done balance.
Our next test is on Christmas.
Clearly that's just my handwriting.
What?
Big test in
We
Christmas.
have a test on Christmas.
Santa's getting us a test.
You're gonna have to be join the Google Meet.
Ever.
Okay.
It's what? We don't have a test.
Oh, false alarm.
Okay.
Yes.
All right, guys. So we're gonna talk about how to simplify now when we have more stuff going on here. So these are able to be simplified. So they're not asking us to rewrite it, but sometimes rewriting it will be helpful. So what I'm going to do with ones like this is I'm going to try and break it up as separate radicals. So kind of break this up as, since there's two bases, I'm going to write it as two different problems. Now the cube root of 125. Is that a nice number? We did that one before, I think. It's 5. So the cube root of 125 is 5. Now, the cube root of a to the 6th, or the cube root of a to the 6th power. How can I think of that another way?
A to the 18.
Yeah, well, 2.
Yeah, because this is really like a to the 6th over 3, because of the fact that 3, like, so 3 is the root, 6 is the power, so 6 over 3 is really just a to the 2nd. So this problem becomes 5a to the 2nd.
That's so nice.
Is nice, nice of them.
Yeah, it's so nice when Mrs. Donahue made this.
Make this math up, like just created it.
Oh, did you make this notes?
Yeah.
So you made it?
Yeah.
All
I
right,
invented
Kenzie.
it. All right, so now how many different radicals am I gonna have this time?
4.
3? Where's the 4th one?
Yeah.
The 3 and the 2 are
I
separated?
just kind of said 4. I didn't really. But then Dylan said it after me, so I thought maybe
We
I was
also
right.
agree. We're going with yes, Dylan agrees.
'cause-
Thank goodness. All right, cube root, or sorry, 5th root of 32. 2, that works out nicely.
It's so
Okay. The 5th root of x to the 10th.
X
X
to the 5 tenths.
X to the 2nd.
So the 10 goes on top, the 5 goes in the bottom. So it's x to the 2nd. And the y, 15 on top, 3 on the or 5 on the bottom.
So 3.
So it becomes a 3.
She told us that one.
Okay. So if you're able, yes, go ahead, Paige. The little fractions. Because remember, going back to the front side, we said that
I walked past it.
okay. So real quick, guys. So just reminding yourself, so if you're wondering where the 10 over 5 is coming from, it's because of the fact that the root is the number on the bottom of the fraction. The exponent is the number on the top. So since this is the 5th root of x to the 10th, we're rewriting it as x to the 10 over 5, y to the 15 over 5. The what? The 2, where did that come from? If you do 5th root of 32 in your calculator, it'll give you 2. Oh, because 10 over 5 simplified. 10 divided by 5 is just 2. 15 divided by 5 is 3. So we're just simplifying those fractions.
Simplify with remainders.
So like if I have a to the 24 over 4, this would be a to the 6th. You can just simplify that fraction. Okay? Now, these all work super nicely because they divided in evenly. 10 divided by 5 is 2. 15 divided by 5 is 3. What happens, oh my gosh, what happens if that's not a nice whole number? Like what if that doesn't go in evenly? So that's where these remainders come in. Speak to yourselves, Abby.
Yeah.
All right.
Maddie likes it.
Maddie, like, how did you get in this? All right. So the cube root of 40, if you guys put that in your calculator, is that a nice number?
No.
No. So clearly you've tried that already. Wasn't a nice number. So we want to find numbers that are nice that go into 40. Now,
5.
okay. So if it's a 3, how many groups of numbers do I want to multiply to get that root?
1 to 4.
What does this 3 tell us? something 3 times. So we're gonna look for groups of 3. Look for triples.
Oh, wait a minute, this is maybe ringing a little bell.
So how about the 4th root? What do you think we're looking for? Groups of 4. And what I mean by that is we're gonna break this up, and I think I heard Abby say it, like the number 5 goes into 40. So we're gonna break this up as 5 times 8. That's not 3 numbers. So I'm looking for groups or triplets of 3. I'm gonna break up the 8 as 4 and 2. Gonna break up the 4 as 2 and 2.
Wait, what?
Okay, take a minute. This is a factor tree. Probably back in middle school or maybe even elementary school math.
So cute.
Are you guys okay with where I got those numbers from? I just keep breaking the numbers down.
Yeah.
Okay, you said wait, so I'm trying to explain. Yeah, we're
What?
good now? Since someone said wait? Someone said wait.
I think it was just like you were going like.
Okay, I still asked. Okay, sorry.
Yeah, you're
I said wait like, holy crap, what are we doing?
Okay, got it. All right, look for groups of 3. Do I have a group of 3?
Yeah.
Yeah, I have a group of 3 twos.
No.
That's a group of 3. So group of 3 is my 2s. That means that gets to pull out because of the fact that I'm taking the cube root of that. So I'm going to pull out the 2. What remains inside then? A 5. And it's the cube root of 5. So this is going to be 2 times the cube root of 5.
Hey now.
And again, that gets pulled out because of the fact that there was 3 2s there. And there was a 5 remaining inside. All right, so a little bit bigger number here, 324. But now since it's the 4th root, I have to look for groups of 4. So 324, tell me something that goes into it. 2? Really, we're starting there?
No.
3.
I don't care. 3 times what? What goes into it?
How about 12 and 27?
12 and 27. Okay. 12 and 27. Long as that actually is what 324 is. Okay, so 12 and 27. And break up 12.
You were correct.
How do you want to break up 12?
3, 4. 3, 4.
Or 3 and 4. How about 27? 9 and 3.
3 and 9.
Okay. How about 4 now?
3, 3. Oh, sorry.
2 and 2. The 3 doesn't break up at all. 9.
3.
There we go.
That's what I was saying, and then you said.
Okay.
It's a group of 4.
Group of 4. Since it's a 4th root, we're looking for a group of 4. We got it. So those get to come out. So we're going to take the 3 out and say we can take the cube root and get the 3. Or the 4th root, sorry. What's left inside?
12.
Who?
4. 4.
Can I get a 19? No. Okay, so I have 2 2s left, which is 4.
4.
So these guys are left inside as remainders. Just start yelling out loud.
We're just like,
Okay. We're going to do a little bit more of this remainder thing, but now we're going to add variables to it.
Oh my god. Great. Like this can be
Okay. And if you haven't done so already, if you can stay really organized with this really helps. The less organized you are, the more of a mess this becomes.
sounds like my life.
Okay. I'm going to break this up.
You guys.
I'm going to break this up as 3 separate parts like I did up above. So I'm going to do the cube root of 54, the cube root of a to the 3rd, and the cube root of c to the 7th. So I'm just breaking those up.
9
Easy.
Now, you can, 9 and 5 is Marco.
Oh yeah.
Nice try.
Silly.
Now, if you check cube root of 54, it's not a nice number. So, cube root 3 tells me to look for 3s, groups of 3. So 9 and 6, that's much nicer. Okay. There's our group of threes.
Yeah, buddy.
So I'm going to take that 3 out. And what's left inside? 2. Inside the Q group that's left inside. I'm going to leave a little space here. If you didn't, it's okay. You just have to rewrite it. I'm leaving a little space. I took out the numbers. Now I'm going to work the variables. What's going on with the A here?
It's getting cube.
It's cubed, but it's also getting cube rooted. So A to the what over what? 3 over 3, which is just going to be A to the first.
Oh my.
So that's going to go in evenly. So that's going to pop out here. So that's going to be A to the first power is going to be out here, or just A. Okay? if you say so. Okay. C to what power? 7 over 3. Okay, now this is where it gets a little bit confusing.
This is where it gets a little.
Right, you're
Yeah.
like 8 times ago. This is where it gets more confusing. I don't know. But so 7 over 3. How many times does 3 go into 7?
Twice.
Twice. So that's how many C's can come out. So I'm going to take out C to the second. If it helps you to write it out this way, there's 7 C's.
It's starting to C to the 23rd.
I know, that's kind of bad there. Sorry.
You just gotta.
That was my,
Okay.
that's my hand.
So I can take the C to the second out. What's left inside? What's the remainder?
1.
Yeah, there's 1 left in because 3 goes into 7 2 times. That gives us 6. And we have a remainder of 1 left. So 3 goes into 7
It better
2
be
times
done
with a
after
remainder
this.
of what?
Please tell us that's.
We're going to do this last example and then that'll be it. for
Tell
today.
us that's the last step.
That's the last step.
Sweet.
I mean, I'm lying to you.
Now we have to simplify that.
Now you get to multiply it by the thing next to it. Okay. What kind of root is this one? 2. The square root, yep. So these are all square roots. So square root of 54 again. Square root this time. Square root of x to the 4th. Square root of y to the 5th. Square root of z to the 7th. If it's square root, what are we looking for? Groups of 2. Remember, square root is the same thing as this. So 54. 9 and 6 again. On groups of 2.
1 and 2.
So I can pull the 3's out, right?
Yes, ma'am.
What's left in?
3 times.
3 times 2, so it's 6. There you go. You okay with that?
Yeah.
All
Yeah.
right. What does the x's power become? How did you get that? Where did that come from? 4 over 2. Remember, this is like a square root. There's a little 2 there. So 4 over 2 is just 2. So the x's get to come out. So x squared comes out. Nothing remains in because it goes in exactly 2 times. This will be y to the 5 over 2. How many times does 2 go into 5? Twice. And what remains?
3.
So 2 goes into 5 twice. That gives us 4. So we're left with 1 inside. So y to the first. And then z, 7/2. 2 goes into 7
3.
3 times. With how many left? Just 1. You don't need those first powers, but you can write them if it's helpful. Okay?
Oh my god.
You can be done for today.
For me.
Okay, so you have a worksheet, but I'm gonna shorten it up because we didn't get to those last kind of crazy examples there.
I thought the last lesson.
You take them all.
That's fine.
So on the homework, you guys can wait on questions 17 through 20. So we'll talk about those tomorrow. They're on the back. They're basically the last 4. Otherwise, the rest of it, I think you guys should be able to do. Oh, if you want hole punches,
I don't care.
so here. If you want hole punches.
Is anyone gonna use a binder?
It would drive me crazy not to use a binder.
There's a folder.
Yeah.
Hey, these are organizational nightmares.
But
Don't worry,
for the first chapter we did, I stapled all the notes together. But I only did it for that one chapter. No, I just put it in my folder.